question, it was asked in the 2003. It is only for the 10 marks, but the question is very big. Okay, but anyway, these type of questions you need to understand easily, so that in the examination you will do very quickly. A steel bolt of diameter 10 mm, steel bolt. See, always, this bolt means the male part. Okay, so this which is having a length like this is called as the bolt. And what is the nut here? This is the nut here. Okay, this is the female part. That is how we distinguish on the mechanical components. Okay, male and female. So the male part is a bolt and the female part is a nut here. So what is the diameter of this bolt? That is a 10 mm, and it is passing through a brass tube. This is the brass tube, and its internal diameter is 15 mm and external diameter is 25 mm here. Okay, and here what is happening? First, in the first case, the bolt is tightened by a nut. I turn this nut so that bolt will be tightened, and when bolt is tightened, what happens? There is a compression. That is actually what is happened, nut, so that the length of the tube is reduced by 1.5 mm. Okay, 1.5 mm. And after that, what I did is, if the temperature of the assembly is raised by 40 degrees centigrade, okay, first I turn the bolt and after that I increase the temperature. Then estimate the axial stresses in the bolt and the tube before and after heating. Okay, before heating and after heating. In both cases we need to find out. And material properties are given here. And one more thing you need to observe, like here, the length of the tube or the bolt is not mentioned here. So that is why I assume that it is 1 meter here. So what happened in this case? I have taken the brass tube, and in the brass tube I arrange some more bolt and then nut here, and there are two cases here. What is that? There are two cases. The first one is I tighten the bolt. Okay, when I tighten the bolt, then there are stresses produced in these materials. What is that stresses produced? When I try to turn this, then the tube will be compressed. And it will try to oppose the compression, so that it is trying to, actually there is a compressive force on the tube like this, compressive force, and because of that compressive force, it is trying to resist that. That means it is exerting some tensile force on the bolt here. Okay, so what is happening? Because of the nut tightening in the first case, compressive in tube means brass tube, and tensile in the bolt. That is what happening here. Two stresses are producing, and these two stresses are equal to one another. Why? Because there is no external force that is acting on this structure. And in the second case, what is happening? I increase the temperature. Okay, due to temperature, what is happening due to temperature? When I increase the temperature, what is happening here? When I increase the temperature, brass and as well as the steel try to expand. And which one will expand more? It is depending on the alpha value. And here the alpha values are given like this. This is the steel value and this is the brass value, and alpha B is greater than alpha steel. Okay, that means brass try to expand more. So brass is outside, it is trying to expand more. Then obviously this steel try to expand less. Okay, it is expanding less. So for example, let's say this is a brass and this is the steel. Okay, so this is the original position, original O, and because of the temperature, this is a brass and this is the steel. And which one is expanding more? Brass is expanding more up to here, and steel is expanding only up to here. But see, these ends are fixed. These ends are fixed means there should be some compromise, then it should come here. So the steel which is here is coming to here, pulled, it is being pulled to the final position, and the brass which is at this position is pulled back. That means compression in the brass and tensile in the steel. Okay, compression in the brass and tensile in the steel here. So here compression in brass means that is the tube here, and tensile in bolt. Okay, so in the both cases what is happening, there is a compression in the tube, here also compression in the tube, and here tensile in the bolt, and here also tensile in the bolt. This is the first step you need to understand the mechanism, like how the compression and the expansion or extension happening in this structure here. Okay, so now what we need to find out, we need to find out these compressive and as well as the tensile forces or the stresses in the both cases. Okay, first we need to take the first case and then second case. Or even if they ask you to find out what is the final stresses, even in that case we need to divide the problem into two cases. What is that? Without temperature one case, and with temperature you deal that separately. Okay, you deal that in the first case I assume that there is no temperature increase and the sole effect is only the turning of the bolt here, and in the second case I will forget about the turning of the bolt and the only sole effect here is increasing the temperature. Okay, I will take that case here. Okay, instead of a bolt here, instead of tightening the bolt, if I have some other case like I applied external force from here and force from other side, in that case what we need to do, again the same division. What is that? Here instead of the stresses due to the bolt, in that case the stresses are because of the externally applied forces. Okay, and we need to divide two cases and then you calculate and finally you combine them based on their direction. What is the meaning of that? If compressive and compressive, then it will become plus. If tensile and compressive, then you need to subtract. Okay, that is the meaning of that. So first I will write here the areas here, area of cross section. For example, area of the steel rod. Area of the steel rod means bolt. Okay, area of the steel rod is how much? Pi by 4 d square. D is here 10 square. Okay, 10 square, and I will keep everything in the mm here. So how much it will become? 78.539 mm square. Okay, and then area of the brass. Okay, then I will write it as a area of T. Okay, otherwise area of B. So what is that? Pi by 4. External diameter is 25 whole square minus internal diameter is 15 square. Then how much it will become? 314.159 mm square. Okay, so these are the areas, and see how we need to find out the stresses in this. So we are assuming only the stress is because of the bolt. Okay, so when I tighten, what happens? There is a force developed, compressive force developed in the brass tube and a tensile force developed in the bolt, and there is no other external or internal forces apart from these two. So what is happening? The force in the brass, let's say the force in the brass tube, B for brass, equal to the force in the steel bolt. Okay, that is what happened here. And if I convert these forces into the stresses, what is the stress? Stress equal to stress. If I convert this force equal to stress into area, that means here sigma B AB equal to sigma S AS. Okay, if I substitute these AS and AB values, then what will happen? Sigma B into what is the AB? AB is 314.159 equal to sigma S into how much AS? That is 78.539. Okay, so after simplification you will get the relation between sigma S and sigma P. Okay, so what is that? Sigma S equal to, from this, sigma S equal to 4 times 4 times sigma b. This is the one relation. Okay, and we need to use another relation. What is the another relation? See here, whenever there is a tightening, bolt tightening problem, then now we come across, we formed some relation. What is that? Total bolt nut turning, total nut turning equal to elongation in the bolt plus elongation in the tube. That is what we derived. But here in this case, nowhere it is mentioned that how much nut has been turned here. Okay, there is no information about this, and there is no information about this also. But instead he mentioned like when you tighten the bolt, what happened? There is a the contraction in the brass tube, that is mentioned here. Okay, when it is so what is mentioned here? So here what is mentioned? This one. So delta in the B means brass tube. It is mentioned 1.5 mm. It is mentioned like a 1.5 mm. So this delta is because of, see, you forget about the temperature. Here we have only the nut tightening. Because of the nut tightening, what is happening? The brass tube is compressed, and it is compressed because of the compressive stress. Okay, whatever deflection, whatever deformation that is formed here is because of the compressive stress that is produced in the brass tube here. So if I write this in terms of the compressive stress, so sigma B, that is B for a brass, into L divided by G. Okay, this is the formula. And here L value, that is why I assume L equal to 1 meter. Why? Because the L is not mentioned in the problem. If I assume L equal to 1 meter, then EB, this is the EB, sigma B equal to what happened? 1.5 divided by 1 meter is equivalent to the 1000 mm. Okay, into EB. EB is 1 into 10 power 5, 1 into 10 power 5 Newton per mm. I will keep in the Newton per mm itself. So what is its value, sigma B? So here sigma B you will get 15 Newton per mm square. Newton per mm square. Okay, this is the sigma B value. Sigma B value is this. And if you know the sigma B from the equation 1, I can find out the sigma S. Sigma S is 4 times the sigma B. Okay, that means it will become 60 Newton per mm square. Newton per mm square. So here see, sigma S means the stress in the bolt. Okay, this is the tensile. And what is the stress in the brass tube? That is a compressor. Okay, this is a compressor. This is the first case. See, and now what is happening? Due to temperature. So when the temperature is increased, what is happening here? When the temperature is increased, for example, both are fixed. It is something like both are fixed. So this is the brass. Let's say this is the brass, and this is the steel. This is the brass and this is the steel, and here alpha B is greater than alpha S. What is the meaning of that? That means when you increase the temperature of the material, then alpha B elongate more distance compared to the alpha S or the steel. Okay, so this is the original position O. Let's assume that there is no restriction for it. When there is no restriction for it, then a brass try to go up to here. Okay, and the steel will go only this much distance. Okay, but both are fixed at the end here. That means they cannot have the individual extensions. That means there should be a compromise here. So it is the final position. At the final position, what is happening? This is the steel and this is the brass. So this will come here and this also will come to the red line and both should be coincident. That means it is a pulled over here and it is a pushed back. That means whenever it is a pushed back, then what is the meaning of that? There is a compressive stress in this and there is a tensile stress produced in this. Okay. So let's say from here to here, this is the delta because of the temperature in case of the steel. Okay, and from here to here, that is a delta in the brass because of the temperature. Okay, but because of the from here to here, finally it is going from here to here, and this delta is delta of the S because of the stress. Okay, so I will say something like a F because of the force. Okay, and from here to here, what is happening? This is one more delta. This is the delta of the brass because of the force. Okay, so the total deflection in case of the steel is from here to here. That means this plus this. Okay, so here I can write the total deflection is the same in both cases. Okay, sorry, not deflection, elongation, or the elongation, it is called elongation or extension. Okay, so in case of the steel, the elongation because of the temperature rise plus the elongation because of the stress that is produced here is this, that equal to, in case of a brass, okay, this is from here to here total. Okay, so that is a delta T of the brass. We need to subtract this much amount. That is a delta B because of the force here. Okay, that is how we need to do here. So here, let's say to distinguish these stresses from these, I will say this is a dash and this is dash. Okay, so here what is the deformation or deformation because of the temperature rise? Okay, that is a L alpha here, yes, delta T. Okay, plus, and what is this because of the force? So here delta, again delta equal to what is the sigma divided by E into L. This is the formula. Okay, the same formula I will use here. So in case of a steel, this is a sigma S that is produced here, and L is same for everything. That is why I am not using any symbol, special symbol. Okay, equal to, and again here what is the sigma T B? This is the L alpha S delta T minus sigma B, sigma B L divided by sigma D divided by E B. Okay, so here if you look at this, L is known, alpha is known, delta T is known. Here L is known, E is known. Which one is unknown? Only sigma S. And here also L is known, alpha known, delta T known, and L and EB also known. Sigma B is unknown here. Okay, so one equation, two unknowns. And where is the other equation? See, another equation is nothing but equation 1 here. How equation 1? See here, what is happening? Because of this. Because of this mechanism, what is happening? There is a tensile force produced in the steel and compressive stress or force is produced in the brass. Okay, and here in the absence of any other external forces, the compressive force is becoming equal to the tensile force here. That means here I need to equate like this, and finally you will get this relation. What is that relation here? I will write here. What is the relation? If I equate the forces, and anyway the areas are similar here. So what is happening here also? Sigma S equal to 4 into sigma B. Okay. So again I need to substitute these values here. So what is happening here? So if I substitute these, I will substitute that at the end. So here I will write like a sigma S by ES plus sigma B by EB, L will get cancelled in all, okay, equal to alpha S delta T. So it is going from here to here. So this is not alpha S, this is a B, alpha B, okay. So alpha B minus alpha S into delta T, okay. What is the value of this? Alpha S minus alpha B is a 1.9 and 1.9 and this is a 1.2, so 0.7. So it will become 0.7 into 10 power minus 5 into 40, okay. And board is not enough, okay. I will erase these values. You remember somewhere you write down this. So here, so if I substitute E values also here, then what happened? If I substitute E values, then here sigma S into 0.5, into 10 power minus 5 is there, okay, plus sigma B into 1 10 power minus 5 will become, after some calculation here on the right hand side, it will become 2.8 into 10 power minus 4, okay. Then I will substitute this sigma S equal to 4 sigma B, okay. When I substitute this, then what is happening? If I substitute sigma S equal to 4 sigma B, then it is a 0.5 into 4 into sigma B. Sigma B I will take a common on both, plus 1 into sigma B equal to, this will go to this side and then it will become 28. So from this, what is the value of sigma B? Sigma B equal to 9.33 Newton per mm square, okay. And what is the sigma S? Sigma is 4 times sigma B. Sigma is sigma S 4 times sigma B, then it value become 37.33 Newton per mm square, okay. So this is sigma S, sigma B are values only in case of temperature by neglecting the first case, okay, by neglecting the first case. And what is the stress that is there in the B? B means it is a brass, so it is a compressive. And what is the force that is there in the steel? That is a tensile, okay. So finally we need to add these two. So final stresses, sigma tube means sigma brass, so sigma B plus sigma B star. What is the sigma B here? Sigma B star is a 15 here, okay, and here it is a 9 plus 15, it is a, how much it will become? 24.33. It is a negative means what is the meaning of negative? It is a compressive. In the same way, sigma bolt equal to, that means steel, sigma S plus sigma S star bar. So how much? Here sigma S star is a 60 and here sigma S is a 37.33, okay. 60 plus 37.33, how much it will become? 97.33 Newton per meter square. In both cases Newton per meter square, okay. It is a positive. Why it is positive? It is a tensile, okay. This is how we need to do, okay. Even though it is looking very big problem, in the examination you can easily do this, okay. What is the main things that you need to remember here? The first case is like see here two things happened. What is that? Simultaneously you twisted it and after that you heated it. So when we twisted with the bolt, there is a stress produced in that because of that, and after that when you heated it, again one more stress produced in that, okay. So first you neglect all the cases by considering only the
twisting of the bolt, and after that you consider the second case by neglecting all other things. What is the second case? The temperature rise. When you consider only the temperature rise, you neglect all other cases like whether you twisted or applied external forces, whatever. So you find out the stresses in individual cases, and finally you add those stresses based on its nature. What is the nature? If compressive, you add. If compressive tensile, then you subtract it. And finally, this much stresses they produce, in the final product. Okay.